Welcome to the next session, my dear friends. See here, in the previous session we have discussed about the turbidity and different ways of measuring turbidity, and a small thing I want to add here is, see, NTU is a Neflo turbidity unit. It is also called a Formazin turbidity unit. It is also called Formazin turbidity unit. And one more thing, these are the limits I have told. So these are the limits which were of the previous code, 1991 code, but the latest revision. But in some examinations they are giving these limits, but in some examinations they are taking the latest limits. Okay, so that is why, so for GATE examination especially, they will take the latest limits only, but in some other examinations, some other competitive examinations, still they are giving options in terms of old code. So that is why, so these two also remember, but for GATE when you are preparing, only prefer this IS 10500. But as per this revision, as per IS 10500 2012, okay, turbidity limits are should not be greater than 1 NTU under ideal conditions. It should not be greater than 5 NTU under unavoidable circumstances where there is no proper source is available. So these are the limits as per IS 10500 latest revision. And also I will suggest you one thing, because every day these codes are getting revised. Every day means not every day, but periodically. So even after this session also, there might be some revisions may occur when you are before going to the examination. So that is why what I suggest is, sometimes we need to refer the code latest amendments also. So we use some codes like IS 456, IS 800, IS 10500, IS 10262 for concrete mixed design, IS 456 for RCC, IS 800 for steel. So this is for water quality parameters. Okay, like IS 516 for hardening tests of concrete. So there are many codes we use. So better, so to have a glance, to have a look at the code, whether simply type the code name and latest amendments if there are anything are there. So record those amendments, because they sometimes in examination they will give from the amendment only. Okay, so that is why, see, these values are for some PSUs and all, but for GATE examination they will prefer the latest code only. Okay, so that is a, remember this for GATE examination. Okay, so this is all about turbidity. Now let us move to the next thing, that is color. Color. See, in color also there are two types of colors. One is apparent color, one is true color. So apparent color and true color means when water is having suspended impurities. See, generally color will come because of dissolved impurities. Whatever the color that comes because of dissolved ions or dissolved impurities such as iron, manganese. Prioritarily, so majorly the water will have color because of two ions, that is iron and manganese. So these are dissolved ions. So these two ions are causing one color to the water. Similarly, there will be suspended impurities also. Along with the dissolved impurities, there will be suspended impurities also. When you look at a river, when you look at a river water, when there are floods, all the river water will color will change to brown, light brown, grey, depending upon the whatever the rocky formations in which it is traveling. In northern region, more amount of mica is present, because of which there the natural sand color is little whitey. Whereas if you go to South India, there will be lot of laterite, basalt kinds of rocks are present. So because of which iron ion will be more, because of which, so you can find the sediment in form of a brown color. So depending upon what kind of sediment it is carrying in it, so accordingly the color of water will change. So that is apparent color. So when you look at a color, so color is of two types. One is true color, another one is apparent color. See, true color is due to dissolved ions or dissolved impurities. Whereas this apparent color because of suspended impurities. So here this apparent color, see, these are the suspended impurities. So the suspended impurities can be removed with time. Under gravity also they can be removed. When the river flood is over, so when the river became peace and tranquil, then in those conditions all the suspended impurity will settle down where it is present. But when there is a turbulence in the river during the floods and all, so again the suspended impurity will lift up into the suspension and the color of the water will change. These are apparent colors. So apparent color means it is a temporary color. Apparent color means it is temporary color which changes. Okay. So, but this true color is a permanent color to the water. True color is permanent color to the water. That is why we don't bother about this apparent color. We bother about the true color. So, though the true color is not harmful to human, but it is aesthetically displeasing. That means we don't like to have water which is colored. Okay, we take some kind of cool drinks and all which is a colored water only. But in general, if you are taking some drinking water which is colored, so we may have a displeasing thing. So we don't like to have a colored water. So that is why generally we want to remove the color and make water colorless. Now here some colors, color causing compounds. So we generally take some food items these days. There will be some color pigments they are adding. So these color pigments generally present in water. So during chlorination, so generally phenolic compounds. So when phenolic compounds are causing color, when phenol compounds are causing color, then during chlorination, during disinfection or during chlorination, they form chlorophenols. They form chlorophenols which are carcinogenic. That means they causes cancer. Which are carcinogenic, that means when normal color causing compounds are there, then there is no problem to us. But when the color is caused because of a phenolic compounds, that means phenolic compounds means the organic compounds which are having a OH ion in it. So when they are being treated with chlorine, so this OH ion gets replaced with OCl minus ion. So now this is nothing but chlorophenols. So these are carcinogenic. They causes cancer. So that is why we need to remove the color causing compounds before sending it into chlorination. So when the color causing compounds are phenols. Now, so that is why here whatever the color we talk, that is of true color. Whatever the color we talk, that is of true color. So true color, if you want to remove this true color, remove the dissolved impurity. Then the color will always, obviously they go away. So now how to remove the dissolved impurities and all, that is treatment part. We only discuss here how to check how to test and how to give the reading and what are the limits. Quality characteristics means what is the character, how to determine the character, and what are the limits of that character given by the Indian Standard Code. So those are the things we need to learn in this topic. So let us go ahead and learn what is meant by true color. So true color only we measure. So that is why the units of this color is we take it as true color unit. So we take it as true color unit. The unit of the color is taken as true color unit. What is meant by true color unit and all, let us discuss. Here also color is found out using color matching technique only. Color is determined using color matching technique only. So this is 1 TCU, 1 true color unit. 1 true color unit is equal to 1 mg of platinum is added in the form of chloroplatinate ion. In the form of chloroplatinate ion, 1 mg of platinum is added in the form of chloroplatinate ion in 1 liter of distilled water. In 1 liter of distilled water. Okay, this is called 1 mg per liter of chloroplatinate ion in 1 liter of distilled water. This is called 1 true color unit. This is called 1 true color unit. Generally, this true color, so this color we measure using this platinum scale. Color we measure using a platinum scale, and also we call that scale as Burger's scale. We call that scale as Burger's scale. Here what we do is we take these water samples. So how to determine the color of a water? How to determine the color of a water? So color of a water can be calculated using tintometer. Okay, the equipment is called tintometer. So tintometer is used here. Tintometer is used to determine color. So how we perform this test is we take Nessler tubes. Okay, we take Nessler tubes. So Nessler tubes are used. Here the Nessler tubes role is to compare the water. So here in tintometer we perform the color matching technique. So here we find the color using color matching technique. Color matching technique. So what we do here is we will take the water which is having color and we take a reference color sample in a Nessler tube. We will compare the Nessler tube reading and this color of the water, so to establish a color matching. So you will add on this platinum in the Nessler tube and we will establish a uniform color between these two. Okay, so 2 tubes are taken. One is with raw water, one is with distilled water. So in this distilled water we add this platinum. So to establish a uniform color, so how much platinum you are adding, that is nothing but the true color unit of this water, raw water. Okay, so similarly we do. So these tubes are called Nessler tubes. Nessler tubes. So in color we do color matching technique. in Nessler tubes using a equipment called tintometer. So we take the water in Nessler tube and we compare, we establish a color matching using tintometer, and the scale is platinum cobalt scale or simply platinum scale. So here the scale is platinum or platinum cobalt. So we can use both scales. Okay, platinum or platinum cobalt scale, and this scale is named as Burger's scale. So this is named as Burger's scale. Okay, so also this unit is also called as Hazen. Hazen has given a scale, okay, based on this platinum cobalt only. Hazen has given a scale. That is why we also call true color unit as Hazen units or Hazen color unit, because Hazen has given turbidity scale, Hazen has given color scale. So there are different scales of Hazen. So that is why I am taking this Hazen unit here, because in IS 10500 color was given in terms of Hazen unit. So color limits were given in Hazen unit. So that is why I am discussing here Hazen unit. But generally we call it as the TCU only generally, but in IS 500 it was given as Hazen unit, and the limits as per IS 10500 2012, the limits are, it should not be more than 5 Hazens and it should not be more than 15 Hazens. So these are the limits. It is not needed to repeat again and again. So this is for ideal, and this is the acceptable limit when there is no alternative source is available. Okay. So this is all about color. This is all about color. Next we are going to discuss about taste and odor. Next we are going to discuss about taste and odor. See, in examination what kinds of questions are important is, so true color, what is the technique we use in finding the color of a water, color matching technique. What is the scale, platinum or platinum cobalt scale, or also they can name it as Burger scale. These are all one mark questions. So this is the unit. What is TCU? 1 TCU means, and in the options they may give you 1 mg of silica added in 1 liter of distilled water, 1 mg of platinum ion added in 1 liter of distilled water, 1 mg of formazine is added in 1 liter of distilled water. So which of the following is 1 TCU? So these kind of questions they may ask. And what are the limits? The limits are also important. So these are the questions which are important from this concept I am telling. Similarly, in the previous concepts also the same thing. What is the equipment, and what is the scale, and what are the units, and what is the technique, and what are the limits. These are the things are important in this chapter in characteristics. Next is taste and odor. See, generally odor can be measured in 2 ways. Odor can be measured in 2 ways. One is dilution factor. So dilution factor means, for example, if you have taken a pungent water, a water which is having strong smell, or else you entered your home and you found that you haven't entered your home for 1 month and you have entered into your home. So then definitely you will get a bad smell from your home when you are not using it for a period of 1 month. Then immediately what you will do? You will open all the windows and doors. Why we are doing this? Why we are doing this? To dilute the smell, bad smell, to dilute the bad smell by allowing the fresh air into the house. So that this is what is nothing but dilution. The same thing when you are getting a water which is having very pungent smell, then what we will do? We will add that water into some distilled water such that the concentration of that impurity which is causing the pungent smell will now get reduced. So that is the technique. So how much distilled water is needed to make it agreeable, to make that pungent smell to make it agreeable. That means it makes it no order, or else some amount of order which is acceptable. So that is nothing but dilution. Okay, so here taste and order. Taste and order, generally we use two things. For order, we use either dilution ratio or dilution factor. Or there will be another way of finding order is using osmoscope. So this is an equipment which will measure the order of the water. So two things we can do. So let us first read about osmoscope. See, osmoscope will give you a reading between 0 to 5. So osmoscope is an apparatus which will give you a reading between 0 to 5 for the amount of order present in the water. So osmoscope reading, if it is 0, then we call that as no order or no observable order, no perceptible order or no observable order. When it is 5, it indicates very pungent smell. Very pungent smell. So that means, so why I am saying this is important for 1 mark. So how the osmoscope reading will vary? 0 to 5, 0 is no order, 5 is pungent smell, or 5 is pungent smell, sorry, 0 is pungent smell, or 5 is no order. So likewise, they may ask the sequence, how the sequence will go in osmoscope reading, those kind of things they may ask. So apart from this, come to here. So majority we do dilution technique only to find the taste and order, because both can be find. So taste can be find also. So we can also find taste by using dilution ratio or dilution factor. Dilution ratio only. So that is why this method is we perform generally to find the order and taste of water. So what is dilution ratio or dilution factor? So dilution ratio is equal to A plus B by A. So it was given like a formula called A plus B by A, where A is volume of raw water, where B is volume of distilled water, So here A is volume of raw, volume of distilled by volume of raw. Okay, volume of raw water plus volume of distilled water by volume of raw water. For example, 20 ml of raw water is added with 80 ml of distilled water. 80 ml of distilled water. Then dilution ratio is equal to, so volume of raw water is how much? 20. A is 20. So volume of fresh water is 80. So 20 plus 80 by volume of raw water, that is 20 again. That means the dilution ratio or dilution factor is 5. Dilution ratio or dilution factor is 5. So likewise, generally we measure the dilution ratio or dilution factor. Okay. Now, so this is also called, for order we call this as the threshold order number. Okay. This dilution ratio is named as threshold order number. So that is TON. This is TON. So the dilution ratio, when you are doing for order measurement, we call this dilution ratio as threshold order number. when you use the same dilution ratio for taste, then we call this as flavored threshold number. Flavored threshold number, that is FTN. Flavored threshold number, that is FTN. So the same thing, we are doing it for order, then it is threshold order number. The same thing if you do for taste, then it is flavored threshold number. So both the numbers, either the order and this the taste, in previous code it was given as TON and FTN, both. TON and FTN both should be in between 1, 2, 3. It should be in between 1, 2, 3 as per previous code. But latest code, it hasn't given any limit. They have told only agreeable. So this is from as per latest code, agreeable. That means if you accept it, it is okay. If you cannot accept it, it is not okay. So agreeable is the only thing. Limit, there is no limit. Agreeable limit is the limit for that. Okay. So this is about color. So the last here, the last one is, and also one more thing I want to add here. When generally while doing this test, we don't do separately for taste. We assume that when the order is not good, then the taste will be not good. So generally, when the order test, whatever the threshold number we get from the order, similarly the same threshold number we will give for the taste also, because generally if the order is not good, we assume that the taste may not be good. If the order is good, we assume that the taste will be good. So that is why by doing only order test also we can give the result of taste simply by assuming that. So there is order, it is failed in order, that means the taste may not be better. So that likewise we give a result. Okay, so this is about taste and order. Let us discuss the last physical property, that is temperature. See, temperature of water, generally drinking water temperature should always be below 10 degrees centigrade or else maximum 10 degrees centigrade, because if the temperature is more than that, it indicates that there is some activity it is happening. That means there is some organic activity that is happening inside the water. Organic activity, if there is any organic activity, then only generally the temperature will increases because of the reactions happening in the water. And also if the temperature is more, it helps the microorganisms to grow in the water. So biological activity will take place, as well as because of the biological activity, so the microorganisms will also survive happily at the temperature. So that is why we don't want warm water, we want rather cool water which is having a temperature less than 10 degrees centigrade, okay, or 10 degrees centigrade also. So it should be less than 10 degrees centigrade. Why it should be less than 10 centigrade? I already told you. When water is warm, it helps for microbial growth and organic activity. So because of which the water quality will get further deteriorates. That is why generally we keep temperature less than 10 degree, but not too much less. So it is acceptable 10 degree, because if it is too less, then what happens? The viscosity of water increases, which makes it unfit for flowing through the pipes. So it cannot be too much less than like 0 degree, 2 degree, 3 degree. Nearly 10 degree is acceptable. Nearly 10 degree is acceptable. Okay. So that is about the temperature. And we measure temperature using thermometer and all. We know all those things. That is not needed here. And so these are all about the physical properties. Let us go to the chemical properties. chemical properties. The first chemical property, that is, see, anyways, actually the first chemical property I need to discuss is dissolved solids, but I have explained about the dissolved solids and how to determine the dissolved solids, and the limits of dissolved solids are also we have discussed during the discussion of suspended solids. So that is why I don't want to start with the dissolved solids. We will go to the next one, that is pH. We will go to the next one, that is pH. So what is pH? What is pH? See here, it's chemical or it's chemical. The concentration of hydrogen ion chemical see, pH is nothing but negative logarithm of hydrogen ion concentration is nothing but pH. Okay, so the negative logarithm of hydrogen plus ion concentration is nothing but pH. So pH means what? It will tell you about the state of the water, whether it is in acidic state or alkaline state or a neutral state. So by looking at the pH of the water, so we can assess the water quality. Now from here onwards, to some extent, because we are discussing about the chemical properties, we need to have some knowledge of chemistry. So from now onwards to the next session also, we will be dealing with all the chemical terms and chemistry. So please give more attention to the class, because these things you might forget long back you have studied chemistry. So that is why you need to give more attention to the class. I will derive some of the terms which we need to use in this pH calculation. So here generally what is the pH? So when the hydrogen ion, so when the water is make ionization, so when you ionize water, it will become H plus and OH minus ions. So upon ionization it will become H plus and OH minus. So here there will be a rate constant. We always define a rate constant. So rate constant, what is meant by rate constant? What is meant by rate constant? So the rate constant is nothing but concentration of reactants, concentration of products upon concentration of reactants. So the rate constant K is equal to concentration of products upon concentration of reactants. Concentration of reactant, that is nothing but the rate constant. And for pure water at 4 degrees centigrade, that means when you take concentration of H2O is 1, when you take the concentration of H2O as 1, when you take the concentration of H2O as 1, then you will get K value as 10 to the power of minus 14 mole per liter. 10 to the power of minus 14 mole per liter. Okay. So when you take the concentration, unit concentration of H2O, then you will get the value of K as 10 to the power of minus 14 for pure water at 4 degrees centigrade. That means for pure water, what is the product of hydrogen ion concentration and OH minus ion concentration? It is equal to 10 to the power of minus 14 mole per liter. Okay. So a unit of hydrogen water molecule, if you have taken a unit or a single mole, if you taken, then this unit will get divided into two parts, that is H plus and OH minus, which are having a product of concentrations which is equal to 10 to the power of minus 14 mole per liter. If we apply logarithm on either side, then it will become, so log of H plus log of OH minus is equal to minus 14 log 10 base 10. So which is equal to 1. This is equal to 1. So this minus, if you bring it here, if you minus, you will bring it here, minus log H plus minus log OH minus, which is equal to 14. So this is nothing but pH and this is nothing but POH. pH is negative logarithm of H plus ion. What is POH? Negative logarithm of OH minus ion. So this is pH, this is POH. So pH plus POH is equal to 14. So this is one thing you need to remember, and this is another important formula you need to remember for the calculations. Okay, and this is one formula which is also important, and this is another formula which is also important for the examinations. Okay, so these formulas generally we use for pH kind of problems. Anyways, while doing the problems we will understand all these things, don't worry. While doing the problems we will understand all those things. And one more conversions we need to learn here. Generally here everything, if you look, they are in mole per liter. So conversion of mole per liter into mg per liter, because we want all the limits in mg per liter, because we see the limits in the code in the form of mg per liter, but in chemistry majority of the cases we find mole per liter. So how to convert this mole per liter into mg per liter? Mole per liter into mg per liter. See here, x mole x you have taken, this is mole per liter, x is mole per liter. So this mole per liter, x mole per liter, if you take this and if I multiply it with the molecular weight of a compound, molecular weight, see the molecular weight will have a unit of gram per mole. So this mole will get cancelled. This is gram. If I want to convert this gram into milligram, so if I want to write this in form of milligram, then this can be written as 1000 milligram. Okay, this can be written as 1000 milligram. So now x mole per liter, if I multiply it with the molecular weight, it will become gram per liter. If I make this gram into 1000 milligram, then it will become milligram per liter. Are you getting me what I am saying? So x mole per liter I am converting it into mg per liter. Simply by multiplying it with molecular weight. So this is x in mg per liter. So x mg per liter is equal to x mole per liter into molecular weight into 1000. That is one formula. And if it was given as equivalent weight, first of all let us see what is meant by equivalent weight. First let us know what is meant by equivalent weight. See, equivalent weight means molecular weight molecular weight upon valency. Upon valency. So this is molecular weight. For example, if you take a calcium ion, so what is the molecular weight of calcium? So molecular weight of calcium is equal to, so calcium atomic number is 20. Calcium atomic number is 20. So when the atomic number is 20, that means there will be 20 protons and 20 neutrons. That means its weight will become 40 gram. Its weight will become 40 grams. So 1 mole of calcium atom, 1 mole of calcium atom will have a weight of 40 gram. Now here this is molecular weight. Equivalent weight means equivalent weight of Ca2 plus is 40 is the molecular weight by valency. This is valency. The charge is nothing but valency. So 2, that means 20. So 20 gram per mole. So here 40 gram per mole is a molecular weight, 1 mole weight. So molecular weight means what? 1 mole's weight. So 40 gram per mole. Equivalent weight means how much is the equivalent weight per mole. So it is 20 gram per mole is the equivalent weight. So if I given you equivalent weight, if I give you equivalent weight X, again the concentration will be always in mole per liter only. Concentration, this is concentration. So what is this? This is concentration of H plus and OH minus. This is mole per liter means it is concentration. Okay. X mole per liter. So this mole per liter is the concentration in terms of equivalent weight. This mole per liter is concentration in terms of equivalent weight. Then equivalent weight gram per mole. So this mole is in terms of equivalent weight. So again this is a gram, I need to convert this into milligram. So mole cancelled, gram will become milligram, so milligram per liter when equivalent weight is given. When milli equivalents are given, when milli equivalents, X in milli equivalents per liter, X is given in milli equivalents per liter. So into equivalent weight, it is gram per mole. See, this milli equivalent is also for 1 mole, this one and this one will cancel. This milli will go and attach to gram, that will become milligram. So this equivalent weight and this mole, this both will cancel. I told you here this is also equivalent weight, this is also equivalent weight, both will get cancelled. This milli will directly go and connected with gram, then it will become milligram. So milligram per liter. So when it was given in terms of milli equivalents, when it is given in terms of milli equivalents, so directly multiply it with the equivalent weight, you will get the mg per liter reading. You will get the mg per liter reading. So these are the conversions of mole per liter into mg per liter. So mole per liter can be written for the total molecular weight or can be written for equivalent weight. Both are there. One, for a mole of any compound, for a molecule, there will be 2 weights. One is molecular weight, another one is equivalent weight. For 1 mole, I am telling you again and again. Why? Because here this is also 1 mole weight. 1 mole's molecular weight. This is 1 mole's equivalent weight. This is also 1 mole's equivalent weight, but the equivalent weight is very small. That is why we are taking it as milli equivalent. Okay, if you are taking a small quantity, then it is called milligram. It is also weight. If you are taking large quantity, you take it in kg. That is also weight. So everything is in form of a mole. Here we take the gases. In chemistry, generally the compounds are taken, concentrations are taken in moles and normalities. Okay, so that is why So that is why we take it in mole per liter. So let us write these formulas separately, clearly. So x mg per liter is equal to x mole per liter multiplied by molecular weight in gram per mole 1000. X mole per liter, this mole is in terms of equivalent weight. Equivalent weight gram per mole into 1000. This is equal to x milli equivalents. This is also for mole per liter into equivalent weight gram per mole. So these are the values we need to remember, because these are very, very important formulas. And also pH formulas. pH is equal to minus log of H plus ion concentration, and POH is equal to minus log of OH minus ion concentration, and H plus ion concentration into OH minus ion concentration is equal to 10 to the power of minus 14 mole per liter. And also pH plus POH is equal to 14. So these are the formulas we need to remember. And also there are many more formulas yet to come in chemistry. So number of what is molarity, what is normality, and all the, now what is meant by gram equivalent, and how to take the during titration, how to convert the concentration of one compound into the concentration of other compound. All these things we will learn in the next lecture. Thank you so much.